Okay, students, we've had some questions about lesson 13, quadratics, increasing, decreasing, and x-intercepts. Let's look at this video together. Okay, we're going to begin with the idea of a quadratic. Ax squared plus bx plus c is equal to 0. That would be a quadratic equation, But we could very easily just not have the equal 0, and we could have in the front, we could have f of x equals. Okay, so now it's a function. And again, it's like it's inside a box. We plug in values, we get back values. Now, what we need to know about a quadratic is special because of the squared. It has really a certain shape. Okay, we've seen the shape before. Now, one thing that we know is this number in the front, a. If a is positive, it's going to look like a valley. Okay, if a is positive. If a is negative, it's going to look like a mountain. Okay, so that's important to keep in mind there. Now, probably the most common, the easiest to understand function of a quadratic is one we are all familiar with, f of x equals x squared. And we know what this looks like. Here's my coordinate plane, and here's my parabola, okay? All right. Now, we notice here that this point is an intercept of both the x and the y axes. And we notice that the function is going up here. In other words, the y values are getting higher. Here, the function is going up also. And that's important to keep in mind. Which brings us to our question that we have. Increase and then decrease. What's going on there? Well, the easiest way to really explain that is to use something familiar to you. I'd like you to think about your grade in here in the course, and then each of these marks right here represent my report to the class as weeks have gone by, right? Okay, so let me just pick another color here real quick. Let's just say that, I don't know, 3.0 or whatever, that would be your grade right here. So you were going right along there, and then, hey, you got so excited about the class, it went up here. You were going sort of constant here, and then you took the midterm, and it maybe took a little dive down this way. But then you kind of leveled off a little bit, you got over that, and then you're going to increase. So what does this mean? This means from these x values, let's say week 1, week 2, from week 1 to week 2, it was constant. Then what does this mean? From week 2 to week looks like 1, 2, 3, 4. So from week 2 to 4, you're increasing. Okay, you're increasing. I'm going to say increase. And then of course we have another constant period right here. And then notice here, let's just call this week, 8? We'll just use that number. So from 8 to looks like 9, we really took a nosedive. So we would say, in that interval, the function decreased. So just try to think about it that way. I had my GPA, or my grade, and time. Time was a thing that was changing. Maybe that'll help you out. So on a quadratic, the function looks like this. Let me just put this over here, okay? Right, now remember, it's like a valley, so it's going to be decreasing to that point, and then it's going to be increasing here. So we're going to call that the minimum. And of course, the maximum, the other shape works the same way. But we are increasing here until we come to the top of the mountain, which we're going to call the maximum, and then we're going to decrease here to the right. If you could think about this, maybe the values of the function represent the money that you have in the bank account, or your retirement, or something along that lines. Now, in order to find this maximum min, we use this little formula, negative b over 2a. Negative b over 2a. And that The A is right here. We're talking about that, and the B is right here. That is how we find the X value. So keep that in mind. Okay, I'm going to get at some assignment problems in just a brief moment, but I want to make sure we get the general gist. So here's the function. Can I graph it? Can I graph it? Okay, well, you can plug it in your calculator, which is fine, okay? And what's going to happen is it's going to have a x-intercept there, and it's going to have a y-intercept here. So the function, of course, it's symmetric, right? It's going to look like this, okay? So that's my parabola. Now think about it. This is a minimum point at 1, 0. That's a minimum point. Notice it's decreasing from negative infinity to 1 and is increasing from 1 to infinity. Negative infinity to 1, okay? And then 1 to infinity. Now, notice this point right here. We're going to call it the x-intercept because it's a place where the graph intercepts the y-axis. So, in order to find the x-intercept, we have to set the function equal to 0, right? Because the y value is 0. Let me give you an example. So here we go. We have f of x is equal to x squared minus 4, okay? Now, so we're going to set the function equal to 0. Here you go. X squared minus 4 is equal to 0. Well, what's going to happen? X squared is equal to 4, right? Take square root, x is equal to plus or minus what? 2. Now, if we remember from the last unit, we know that that function is just simply a parabola moved down 2 units. A parabola moved down 2 units. So this is what this looks like, okay? All right, now notice this is a y-intercept, that's an x-intercept, that's a negative x-intercept. That intercept is 2, that intercept is negative 2, and that's, actually that should be negative 4, okay? Right, because it's x squared minus 4. So negative 4. Those are just the concepts. Now let's work some problems in the next slide. Okay, so here's the question that you'll see. Determine the x and y intercepts. Here's my function right here. Well, the y-intercepts are very easy. Just plug in a 0 for x. That would be 0 squared plus 4 times 0 minus 12, which is negative 12. The y-intercept is negative 12. The location of that point is 0, comma, negative 12. All right, can we find the x-intercepts? So remember from the last slide, to find the x-intercepts, you got to set the function equal to 0. Okay, now let's see. I wonder if we can factor x minus 6 and x plus 2. Okay, would that work? No, it would actually be plus 6 and minus 2. Okay, again, that goes back to factoring trinomials. All right, so what does this tell us? Negative 6 is one answer and 2 is another answer. Those would be the places on the x-axis, negative 6, where the graph would cross, 2, where the graph would cross. Now, what would be the actual location? 2, comma 0 and negative 6, comma 0, because the y's are 0. That's x-intercept, okay? Let's look at another problem. Okay, this is an excellent question. Find the intercepts. Now, I don't want to string you along here, but I want to remind you, you would have a problem solving that equation, and you would have a problem graphing this. Now, why would I have a trouble graphing this? Because it's a parabola moved up 1. It's a parabola moved up 1. Is that graph ever going to cross the x-axis? The answer, no. So really, it doesn't have an x-intercept. Now, let's look at this problem here. What we want to do is find the x-intercept. So let's just say, for instance, we're going to set this equal to 0, okay? Well, we can't factor it, so we're going to have to use the quadratic formula. So that's what? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. All right, so that's negative 3 plus or minus the square root of b squared, which is 9, minus 4. This is how I do it, a times c. A times c is 4, okay? All over 2a, which is just 2. Now look, let's look at this little radicand. It's 9 minus 16, which is a negative what? 7, okay? 9 minus 16, negative 7. Right now, I had trouble taking the square root of a negative number, okay? And the reason why is the xy plane only graphs real numbers. And this would give us an imaginary. That is why this graph has no x-intercept, and that's why this function has no x-intercept. Okay, I hope that explains that. Okay, now this is a very good question. Find the maximum or minimum. Okay, well, look, here's my function, okay? We're going to use negative b over 2a. Now remember, b is negative 4, so negative 4 over 2a, and that's going to be 3, so 2 times 3. Okay, this, of course, this is 4 over 6, and this is 2 over 3. Now, what this tells us, because we know there's a plus in the front there, the graph is going to look like this, so I'm going to have a minimum. Now, I have an x and I have a y where that happens. The domain value is the x. The actual minimum is the y, because it's the function. And what we need to do is, we know the x is 2/3. We're going to have to find the y. And the way to do that is to put the x value in for the function and then determine the y. So remember, it's 3 blah squared minus 4 times blah minus 2. Okay, what are we going to plug in there, folks? We're going to plug in there 2/3. Okay? All right, so this is going to be 3 times, what is that? 4 over 9 minus, that's going to be 8 over 3, and that's going to be minus 2. Well, this does simplify. That's just going to be 4 over 3. So 4 over 3 minus 8 over 3 minus 2, which is negative 4 over 3 minus 2, which is 4 over 3 is 1 1/3, so minus 3 1/3. Okay, now that is the y value. We could say, if you want to, negative 10 over 3. You could say minus 3.33. Okay, whatever. All right, so find the minimum or maximum. The minimum is this number, okay? The location is that number. I hope that helps you out a little bit in this lesson 13. Email me if you have another question. Thank you.